In this lesson we're going to look at how a salt can be produced by reacting an acid with a carbonate. So the general equation for the reaction of acids with metal carbonates is that we have an acid plus a carbonate will give us a salt. That's what we want, that's what we're after in this reaction. Carbon dioxide and water. So again, as with the reaction of acids with metal oxides, we need to think about which acid and which carbonate we're going to use in order to produce our salt. So let's just suppose in this case that we want to make calcium sulfate. So the cation, that's the calcium ion, will come from the carbonate, and the anion, that's the sulfate ion, will come from the acid. Okay, so let's write out the symbol equation. So we've got sulfuric acid, H2SO4. That's going to react with calcium carbonate, which is going to produce calcium sulfate. That's what we're after. So the calcium from the calcium carbonate joins on with the sulfate group from the sulfuric acid to produce calcium sulfate, carbon dioxide and water. The equation is balanced, we don't need to touch that. And so now let's just look at the procedure that we're going to employ in order to obtain a solid sample of calcium sulfate. We should state here again, these are aqueous solutions. This is an aqueous salt solution. So what we actually want is a solid sample of calcium sulfate. So let's look at the full procedure to obtain a solid sample of calcium sulfate, which is pretty much the same as the procedure we used when we mixed an acid with a metal oxide. Okay, so we're going to add powdered calcium carbonate, or powdered limestone if you like, to a dilute solution of sulfuric acid. Okay, when you add that calcium carbonate, you're going to notice that there's effervescence because carbon dioxide gas is released, and so there's going to be a lot of fizzing going on. You add the measure, stir it around. When the fizzing stops, you add some more, and you keep adding calcium carbonate until all of the sulfuric acid has been used up. You don't want sulfuric acid hanging around in the solution. So we keep adding calcium carbonate until there's no longer any effervescence produced. There's no longer any carbon dioxide released. And once that happens, we know that all of the dilute sulfuric acid has been used up. And we then have an aqueous solution of calcium sulfate. But of course, that aqueous solution is mixed with the residue of calcium carbonate at the bottom of the beaker. So we then take this mixture and we will filter it. The calcium carbonate residue will remain in the filter paper, and our filtrate will be a solution of calcium sulfate. We still aren't there yet because we want a solid sample of calcium sulfate, so what we then do is we heat the filtrate in an evaporation dish. We heat that till it just starts to boil. We turn off the Bunsen burner and the water will slowly evaporate, leaving a solid sample of calcium carbonate at the bottom of the evaporation dish. Okay, so we've obtained what we wanted by mixing dilute sulfuric acid with calcium carbonate, dissolving until all of the dilute acid has been used up, filtering so that our filtrate contains aqueous calcium sulfate, crystallization by evaporating in an evaporation dish so that the water is removed from the solution, leaving a solid sample of calcium sulfate at the bottom of the dish. Just as with the oxides, we may want to obtain other samples using this method. So supposing we wanted copper chloride, then our acid would be dilute hydrochloric acid and our carbonate would be copper carbonate. Or magnesium nitrate, then our acid would be dilute nitric acid and our carbonate would be magnesium carbonate. Or calcium sulfate, well, we've just seen that was dilute sulfuric acid, calcium carbonate.